This lesson's going to be focused on the normal curve and how we use it in math to make predictions and generalizations about data. So, a little bit of a review before we dive into that. In a previous lesson, we discussed skewed data. And so, a reminder, when we had outliers on the low end, and a lot of the data was grouped up sort of on the higher end of the graph, we referred to that as left skewed data. And when the reverse was true and we had high outliers and their data was sort of bunched up in the low area, we referred to that as right skewed data. But what we're going to be focused on today is when the situation when, the mean was almost equal to the median and we sort of had data that was balanced out. What we referred to in our previous lesson as symmetric data. And when we have symmetric data, we can generalize it with something known as a normal distribution. And basically, we make a sort of bell curve. And there's special characteristics to that normal distribution that allow us to make some sort of predictions and generalizations about the data. The key sort of to be able to do this setup is that we know that the data is equally sort of spread out on either side of the mean. And then, and then we sort of know that 50% of the data is about, above the mean and about 50% of the data is below the mean. And when we're dealing with this, we're going to be using sort of two measures to sort of build our normal distributions off of. We're going to be using the mean and we're going to be using the population standard deviation. And the reason we use the population standard deviation in this case is because when we use normal distributions, we're generalizing our sample set to the larger whole group within the sort of bigger population. The first thing that we have to be able to do is we have to be able to take our mean and population standard deviation and turn it into this sort of normal curve. So a pretty common situation when dealing with normal distributions are standardized tests, because the scoring of a standardized test is actually intentionally set up to be normally distributed. So you can actually look up online SAT scores, and you'll find they'll tell you that like the mean score and they'll tell you what the standard deviation is. So back in 2021, the mean score of the SAT was 1060 and it had a standard deviation of 217. Now a little reminder, remember standard deviations is telling you sort of the spread away from the mean. So you almost want to think like distance from the mean. Now, when setting up your normal curve, this is sort of the basic setup, and then we label things. And you want to start in the middle. And the very middle value is always going to be the mean. So in this case, that would be 1060. And so we always start and we have the mean here in the middle, because that's the middle value in our data set. So we think of that as the middle. Now, going off in either direction then, what we care about is that sort of standard deviation. So each step on our normal curve past the mean, if we're going above, we're going to add one standard deviation. So like each time we're going to add another standard deviation. And typically on a normal curve, we show out 3. So in this case, I'm going to be adding 217. So for the first one, it was 1060 is my mean. And then I'm going to add 217 to that. And I would get 1277. And so that would be one standard deviation above the mean. And then I could keep going. I could add another 217 to that, and I would get 1494. Now we're 2 standard deviations away. And then if I added, another to that, I would get my 3 standard deviations away of 1711. And I get that 1711 isn't a possible SAT score. It caps out at 1600, but I'm still going to just sort of show out that value there. Now, if we're working in the reverse direction, now instead of adding standard deviations, we're going to actually be subtracting 1 standard deviation each time. So it'll be minus 1 standard deviation, minus 1 standard deviation. So that means I'm starting with my 1060 again, but this time I'm going to subtract 217. And so that would get me 843 as 1 standard deviation away. Then if I wanted 2 standard deviations, I would subtract again, and I would get 626. And then I subtract 1 last time to get that 409. And you might be going, why don't we go past that? Well, pretty much almost every single data point is going to fall within those 3 standard deviations. It is super highly unlikely that anything's going to fall outside of that range. And that's sort of why we keep it within 2. In the next video, we'll talk a little more precisely about how much of the data falls within each section of this normal curve.